Good morning all. Let us start with chemical thermodynamics. So chemical thermodynamics is the branch of chemistry which includes two terms, thermo and dynamics. Thermo means heat and dynamics means changes. So the heat changes included in the chemical reaction, those are very well explained by the concept of chemical thermodynamics. Before we come to this concept of chemical thermodynamics, let us say what is an energy. Energy is nothing but the ability to do work. Ability to do work means energy. There are different types of energy or different forms of energy. One is kinetic energy and other is potential energy. So this kinetic energy, as you all know, this is due to the motion, and potential energy, this is the stored energy. This is stored energy. There are different examples of this kinetic energy like mechanical energy, electrical energy, thermal energy, radiant energy, or light energy. This can be also called as light energy or electromagnetic energy. Which travels in a transverse waves. Next can be sound energy. So these are the different types of kinetic energy. Potential energy includes chemical energy, nuclear energy, then gravitational energy, and elastic energy. So this comes under the heading of potential energy. Now these are the energy changes which transforms energy from one form into the another form. For example, in dry cell, chemical energy is converted into electrical energy. In electroplating of metals, electrical energy is converted into chemical energy. Other examples can be burning of carbon, forming carbon dioxide, transformation of solid ice into water. These are the few examples in which energy can be converted from one form into the another one. So thermodynamics is mainly concerned with the energy changes in physical and chemical transformation. It will not give you any information on the rate or the mechanism of physical or chemical processes. It will just tell you about the heat changes or the energy changes occurring in chemical reaction. So thermodynamics is nothing but the energy changes in physical and chemical transformation. So this is about the introductory part of the thermodynamics. Now there are different terminologies which are used in chemical thermodynamics. First is system. System is nothing but the part of the universe which we are considering or which we are studying, that is called as a system. So here system can be, you can write like this, system, and another is surrounding. System and surrounding, these are the two terms which are commonly used in chemical thermodynamics. So system is nothing but a part of the universe which is under study. System is under study, and the surrounding is what? That is the part of the universe other than system. That is surrounding. Suppose we consider study of change in volume of a gas by changing or varying pressure applied on the gas with the help of a piston. So you can refer to the textbook. Also, I'll draw the diagram here. If we take a container in which a certain amount of gas is filled, and this gas is applied with some amount of pressure with the help of a piston. So this gas, which is under study, it is called as a system, and the area or the part other than the gas, the whole thing surrounding this beaker or a container, it comes under surrounding. So all the other parts outside the system, such as cylinder, room and others, are the surroundings. It means universe is made of system plus surrounding. So this is about the system and the surrounding. We'll be using this system term or word often, and the surrounding also when we further study chemical thermodynamics. Now there are different types of systems. One is open system, second is closed system, and third is isolated system. So these are the three different types of systems. This open system, it shows if you take open cup containing hot coffee placed in a room, so the water vapors passes into the surrounding, and such system is called as an open system. Means if you take a hot coffee in a cup and you allow this matter or the water vapor to escape into the surrounding, such system can be called as open system. Second is closed system. In closed system, hot coffee cup, same hot coffee cup, in hot condition, if you cover it with a saucer, water vapor does not pass into the surrounding. Such system exchanges energy in the form of heat, but not the matter with the surrounding, and such system is called as a closed system. You can refer to the textbook also, which is the figure 4.2b. It's a very simple concept, open system and closed system. In open, you will be keeping the cup open. In closed, you are covering the cup, hot coffee cup, with a saucer. There will be exchange of, here in case of open system, there will be exchange or escape of water vapors into the surrounding. Here there will be no exchange or escape of water vapor into the surrounding. Such a system is closed system. Third one is isolated system. Now same this hot coffee cup, if you cover with a saucer, it would be a closed system. But this covered cup with a saucer, if you put it or insulate it from the surrounding, such a system is called as an isolated system. So coffee in this third case or in third type of system, this coffee cup will not cool down. There is no exchange or of neither energy nor matter with the surrounding. Such system is called as an isolated system. So if you want to sum up, there are three systems: open, closed and isolated one. So in case of, I just revised this in a movement. This open system, there will be exchange of the matter with the surrounding. Here there will be no escape or no exchange of matter with the surrounding, but there will be energy changes. But in case of, means the hot coffee will get cooled down after some time. But in case of isolated system, there will be no exchange of matter and there will be no exchange of energy also. So this is the main difference between these three types of system. Now when we proceed further, we'll talk about the properties of system. This is very important concept. Many questions can be asked based on these properties of system. In case of properties of system, there are two types of properties. One is extensive property and other is intensive property. Extensive and intensive property. So extensive property is the one which depend on the amount of matter. So this is dependent on amount of matter. Whereas this intensive property, it is independent of amount of matter or mass of the system. You can use the other word, amount of matter or mass of the system, So here we will be coming to this one by one. For example, mass, volume, internal energy, number of moles. These are the few examples of, or heat capacity also, heat capacity, and all forms of energy. These are the examples of extensive property. In case of intensive property, what are the examples? For example, pressure, temperature, density, surface tension, viscosity, melting point, boiling point. Further, you can write specific heat. These are the examples of the intensive property. So this intensive, this in word is very important when you think of both the properties. Intensive, this is independent. So when you want to learn, or when you want to keep in the concept of this intensive property in your minds, in and in, these two words you always remember, intensive and independent. So intensive properties are those which are independent of matter. Extensive are those which are dependent on amount of matter or mass of the system. Now here we can explain this same concept. For example, mass, it is dependent on the amount of matter. Mass can be 1 kg, 2 kg, 3 kg. Volume can be 1 liter, 2 liter, 3 liters. But pressure, it is independent of the amount of matter. Suppose, for example, if you take 1 liter of the volume, you apply some amount of pressure, or 1 atmospheric pressure or 2 atmospheric pressure. Accordingly, the volume will change. So this is dependent on the amount of matter, but pressure, it is not dependent on the amount of matter. Whether this volume will be 1 liter, you can apply the same pressure at 1 atmosphere. If the volume is 2 liters, this volume can be compressed by the same amount of pressure to some extent. So this pressure is independent of the amount of matter, of the mass of the system, but volume will go on changing because it is dependent on the mass or the amount of matter present here. In very simple words, I can add some more to this concept. If we take two different systems like this, here, this is the first system with some temperature, pressure, volume and mass. Another system with temperature, pressure, the volume can be changed from initial to this half, and mass also can be changed from initial to the half. So these are the two things, temperature and pressure. These are the two quantities, or these are the two properties which are called as an intensive property, because these are independent of the matter or mass of the system, Whereas this volume, it can be changed from V to V half, means it can be half, and mass also can be half from m to m by 2. So these two, volume and the mass, these are the extensive properties because these are dependent on the mass. Now if you see, if you go to the earlier page, I wrote here this density. Density, it is an intensive property. Though this mass and volume both are mass and volume, these both are extensive one. Both these properties are extensive one because means these are dependent on mass or matter present in the system. Whereas this density, which is nothing but density is equal to mass upon volume, but still this density, it is intensive property. Intensive means in and independent of mass or matter present in the system. So though these are both are the extensive one, but this density is an intensive property. I can explain this with a very simple example. If there are 10 students in a room, each one of them is having 10 rupees note, rupees 10, and there are 10 students, so total would be 100 rupees. If you change this, these are number of students, instead of this, if you make this 20, this will be rupees 200. This would remain the same. Again, if you make this 30, it would become rupees 300, because you are changing number of students here. Accordingly, this will go on changing 100, 200 and 300, but mind well, this rupees 10 you are keeping this as a constant. This is constant. So these two terms, you can compare this with the mass and the volume. Mass is changing, volume is also changing, but this density, this rupees, each student is having the same amount of rupees, that is 10. It is remaining constant every step, so this can be considered as a density. So density is nothing but mass upon volume. So there are different examples or different questions can be asked based on this very important concept of thermodynamics, that is properties of system. I'll just sum up with this in very short time, that is extensive and intensive, dependent, independent. Don't forget this in word. So this is about the properties of the system. Then in the next lecture we will start with the state function. Before that, you just revise, you just go through the textbook, read this carefully, and if you want, I will give you some question based on this concept, that is intensive properties and extensive properties.